Hello and welcome to Nkumat Online Academy. In today's lesson, we want to talk about mechanical advantage, MA. Mechanical advantage, MA. Mechanical advantage is part of what we consider in machine. In our last lesson, we talked about machine and we defined machine as anything that helps us to use small efforts to overcome big load. And we talked about the types of machine, simple machine and complex machine. Simple machine and complex machine. And we stated the difference between the simple machine and complex machine. We said that in simple machine, the effort and load are in just one direction. That means that the effort applied produces effects or it overcomes a load in just one particular point. But in a complex machine, effort applied in one place overcomes a load in different places or different points. And we gave examples of simple machine. We talked about lever, pulley, and we also talked about the wheel and axle. We went further to talk about lever, the types of lever systems, the first class lever, the second class lever, and the third class lever. We showed the differences between first class lever, second class lever, and third class lever. Then you should know that pulleys are also other examples of simple machine, pulleys, then wheel and axle, then inclined plane, and gears and screws are also examples of other examples of a simple machine. Now pulleys they look like, if you have ever seen a crane, in a crane we have something that looks like wheel and we have a rope that passes through it. You pull one and it has to move something up or down in pulley. So it actually looks like maybe you have something like this and you have this load, you want to lift it, then this wheel will be rotating. You pass a rope through this wheel, then you want to lift this load. This is a load that you want to lift. If you try to carry it vertically, the load will be very heavy. Then you tie a rope on this wheel. While you are drawing the rope on this wheel and the wheel is rotating, it will be moving this load up, and you don't have to use much strength to lift it. The way here, as it is rotating, it will help to move this load faster and without you using much energy. So that is a pulley system. Then in wheel and axle, like we have in the wheel of a car, there is a connection between where if you are in an area where they use borehole a lot, some people they use the wheel and axle machine to draw water from their well. They tie a rope just like we have in pulleys. They tie a rope in a well, and while they have there's a handle, they are turning the handle and the wheel will be drawing the rope that is tied to a bucket inside the well. That is what we call wheel and axle. Then for screw, just like our screw nuts that we have, in your screw you have your screwdriver. You put your screwdriver on top of it and you are rotating your screwdriver, and then the screw is moving inside the object you want to place it in. So using the screwdriver and just using small effort, you'll be able to move the screw inside the object. But if you want to use your hand and pierce the screw inside the object, it will be very difficult for you to do. But because the screw has been carved in such a way that it aids its movements through the object, it is easier for you to move the screw inside the object. So that is it about pulley, wheel and axle, and the screw as simple machines. Then we talk about the mechanical advantage. Mechanical advantage simply means the ratio of load to effort in a machine or in a simple machine. When we divide the load by the efforts you applied, you get your mechanical advantage. So if you are given any load and you know the efforts applied, you can get the mechanical advantage by dividing the load by the efforts. Mechanical advantage does not have any units because load is measured in Newton and effort is also measured in Newton. So we are now going to have Newton over Newton, Newton on top and Newton down. So we divide two of them. So there is no unit for mechanical advantage. Now let's see examples. If we have that an effort of a man applies an effort of to overcome a load of calculate the mechanical advantage. A man applies an effort of 5 Newton to overcome a load of 20 Newton. Calculate the mechanical advantage. The mechanical advantage, MA, is equal to load over effort, which is equal to, the load is 20 over effort used in overcoming the load is 5 Newton. Newton, 5 Newton. So the Newton will cancel Newton, no unit again. And 20 divided by 5 will give us 4. So the mechanical advantage is 4. There is no unit for it. Example 2. If a man overcomes a load of 20 Newton, calculate the efforts applied if the mechanical advantage is 2. Okay, here we already know the mechanical advantage and we are asked to find the effort. We know the load. Now we put everything into the formula. The formula is that let's represent load with L and effort with E. MA is equal to L over E. Now we know our MA as 2. So 2 is equal to, our load is 20. And effort we are looking for is E. Now the E, we can do cross multiplication. This 2 is, anything standing on its own is over 1. So we now have that 2 over 1 is equal to 20 over E. We do cross multiplication. We bring this one and this and connect this and this. So it gives us 2 times E is equal to 2E, and 1 times 20 is equal to 20. Then our E is equal to, E is this side, 2 is here. If it is coming to this side, it will become division. So it will divide the 20. So we have E is equal to